My alarm goes off at 12:45 a.m. in the morning. Got to be to work by 2. You're working anywhere from a 13.5 to maybe a 16-hour day.
Use liquid Dow calcium chloride solution to enhance their dry ice melt materials or to anti-ice before a storm arrives.
We're out here doing it for the motor public, but we're also doing it for the kids that are going to school, the bus drivers, that mom that's taking their kids to daycare.
Put out down, the liquid's applied to the salt as it's falling down and before it hits the spinner.
Pre-wetting rock salt with liquid Dow provides the needed moisture to more quickly form liquid brine and initiate melting action.
Right, chemical down and everything's melting. You're just basically making it safer for the public.
When rock salt is pre-wetted with liquid Dow calcium chloride, it provides fast ice melting action, improved low temperature performance, fewer losses from bounce and scatter, high quality road maintenance service, and overall reduced ice melting cost. Liquid Dow is made in the USA by OxyChem and has over 100 years of proven performance and quality.
We need a little activation energy to get the magnesiums to react with the oxygen, and there it is. So oxygen's reacting with the magnesium ribbon, and it's releasing a lot of light and heat energy. This is one of the brightest lights that is produced by a chemical reaction. They often use magnesium in fireworks for these bright bursts of white light, and also is extremely hot. You can get very, very, very high temperatures from this chemical reaction. Now, coming off the light, you can see a white ribbon, and that is the magnesium oxide that's being produced. So magnesium atoms are being bonded to the oxygen atoms in the air to form that magnesium oxide product.
Assalamualaikum and a very good morning. I bid to Dr. Haslina and all my fellow friends. So today our group are going to present about S block specifically for group 2 elements. First, me Arifah will explain about hydrides, followed by FARAH who will explain about halides, then FATIN will explain about oxides, and last but not least, Danial will explain about sulfides. So first, what is hydrides? Hydrides is a binary compound that consists of hydrogen and another element from periodic table. And all elements in group 2 except beryllium will form ionic hydride or saline hydride. It is also called as saline hydride due to its salt-like structure like NaCl. However, beryllium will form covalent hydride instead of ionic hydride. I'll tell you why on the next slide. Some of the examples of ionic hydride like magnesium hydride, calcium hydride, and strontium hydride. So this is the general equation of the formation of ionic hydride, which is metal react with hydrogen will produce metal hydride. So these are some physical properties of ionic hydrides. First, it is crystalline. It can also conduct electricity in molten state but not in solid state. It has high melting and boiling point. It is also soluble in water since it forms ionic bond, and it is also non-volatile since it is solid at room temperature. So these are some chemical properties of ionic hydride, which are it can react violently with water to form hydrogen gas, and it can also act as non-nucleophilic bases or reducing agent. So as you can see from the slide, these are some uses of ionic hydride. First, it can be used as a strong basis in organic synthesis. It can also be used as reducing agents in many chemical industry. Magnesium hydride is used as hydrogen storage material, and calcium hydride are used as desiccant or drying agent for amine solvent. So now I will explain about beryllium hydride. Unlike the rest of the member of group 2, beryllium hydride does not react directly with hydrogen. However, in order to form beryllium hydride, a process called pyrolysis need to be conducted. Pyrolysis means the thermal decomposition that is conducted at higher temperature. So in order to form beryllium hydride, pyrolysis of di-third butyl beryllium will need to be conducted. So why beryllium hydride will form covalent hydride instead of ionic hydride? As we know, beryllium is located at the top of the group 2 members. So since it is at the top of the group, it has less electropositivity and it has high ionization energy, which means it requires a lot of energy in order to release its valence electron. So these are some properties of beryllium hydride. It can react very slowly with water. It is also a polar molecule. It is rapidly hydrolyzed with acid to release hydrogen gas. It does not conduct electricity in any state, and it has wide amorphous solid appearance. And beryllium hydride is widely used as a rocket fuel and as a moderator for nuclear reactors. Next, Farah will explain about halides.
Bismillahirrahmanirrahim. Assalamualaikum and a very good morning everyone. I am FARAH SYAZWAHAZWANI BINTI SUFATAN and I will continue today's presentation with halides. So we will start with the synthesis of the barium halides. For beryllium fluoride, we can synthesize it from thermal decomposition of ammonium tetrafluoroberylate 2. And then for beryllium chloride, bromide and iodide, we can synthesize it from the direct reaction at elevated temperature. Okay, for examples, to get beryllium chloride, we can react it the beryllium and also the chlorine at 800 degrees Celsius. Okay, next for magnesium halides, it also can be synthesized from the direct combination of elements. And for magnesium chloride, it can be extracted from seawater and widely used in production of magnesium metals. And then for strontium and barium halides, we can synthesize it from the dehydration of the hydrated salt. Okay, next we move to the chemical and physical properties. So all beryllium halides are covalent. Okay, so did you know why beryllium halides are covalent instead of ionic? So this is because beryllium has high electronegativity compared to the other elements in the group 2. So it will attract the bonding pair of electrons towards itself more strongly. Then it will form covalent bond. Because in order to form ionic bond, it has to let go of its electron. But it is difficult to do so. So it will form the covalent bond instead of ionic bond. Okay. And next, all ferrites except beryllium ferrites are sparingly soluble and solubility increase slightly down the group. And calcium fluoride is the only calcium halides that is soluble in water. And all chlorides are deliquescent and from hydrates and also have lower melting points than fluorides. Okay, so what does the deliquescent mean here? So the deliquescent here means the tendency to form liquid. Alright, so we move to the next slides. So in these slides, we will cover the uses of the alkali earth metals uses. Alkali earth metal halides uses. Okay, so the most important here, you need to know the uses of the calcium fluoride. Okay, because it is rich in mineral form of fluorspar, which is the source of the fluorine in the compound polytetrafluoroethylene, PTFE, which is used as a non-stick coating for pans and other cookware. So next, we see the magnesium chloride use, which is most important chloride in industry and application, and used in the production of magnesium metal. So calcium chloride is also widespread use as drying agents because it has the hygroscopic character. So did you know what is hygroscopic? Hygroscopic is the tendency to absorb water from the air. Okay, so next, magnesium chloride and calcium chloride. These two are used to de-ice the roads due to the isotonic the solution, which is better than natrium chloride. So when we compare these two with the natrium chloride, so these two have very isotonic than lithium chloride, and also minimum freezing point of calcium chloride is negative 55 degrees Celsius compared to natrium chloride, which is just negative 18 degrees Celsius. So then this two is less toxic to plant life and less corrosive to iron and steels. And it is also used as the instant heating pads and self-heating green containers. Alright, so I will pass this presentation to Fatin.
Okay, thank you, Farah. Okay, now let's move on to oxide. Oxide is a chemical combination of oxygen and one other element. We have two, simple oxide and also peroxide. Simple oxide is a reaction between the element in the limited oxygen, and we have the example is the beryllium oxide. The beryllium oxide we can get it from the emission of metal in oxygen, or we can this metal heated in the oxygen to get its metal oxide. And beryllium oxide is also a white insoluble solid with a rosette structure. The structure we can see at the slide, and also it has a low reactivity and good thermal conductivity. And although that beryllium oxide also have a strong layer of oxide on it, and it prevent any other new oxygen to react with it. That's why beryllium oxide is still as a simple oxide and can be the peroxide. The beryllium oxide also uses as a refractory material and is highly toxic as it is have a low density of as is a dust particle that can remain on the airborne for a long time and can cause a disease on the lung and also cancer, and is safe to use in the synthetic monolith section. And also we have the other example of magnesium. We have a magnesium oxide, calcium oxide, sodium and barium oxide. The synthesis of this we can get it from the decomposition of carbonates. And the properties of this oxide is from the magnesium to the barium. We have the rock salt structure. The structure we can see at the slide, and it has a melting point decrease along the groove. The example of the magnesium oxide uses is it can use in the refractory lining in industrial furnace because it have a high melting point, and also due to the good thermal conductivity and also low electricity conductivity, it can use in the electrically insulting material. And also next we have the calcium oxide. The users usually use the calcium oxide as a lime in the steel industry and also to remove the silicon, the phosphorus and also sulfur. And the calcium oxide also we use it as a water softener to remove the hardness, and also we can react the calcium oxide in the water to get the calcium hydroxide to neutralize the acidity in the soil, as the calcium hydroxide is a basic solution. And also the peroxide, we have the soluble and insoluble peroxide. The soluble peroxide, we have the example is strontium and barium peroxide. We can get this is from the direct reaction from its element, but not for the insoluble. We need to add the natrium peroxide to its aqueous solution to get its element peroxide. We have the example is magnesium peroxide. It's a least stable peroxide that we can use as a source of oxygen, as can be broke easily to get the oxygen and also the magnesium oxide from this magnesium peroxide. And lastly, we have the calcium peroxide. We can use in disinfecting water and also a floor bleaching agent. That's all from me. Thank you, and I will pass the presentation to Daniel. Thank you.
Okay, thank you, Fatin. Now I will continue with the fourth binary compound for group 2 elements, which is sulfide. Do you know what is sulfide? Sulfide is a compound that contains only sulfur element. For example, barium sulfide, calcium sulfide, and magnesium sulfide. How can we synthesize the sulfide? For barium sulfide, we can synthesize it by reducing the naturally occurring barytes, barium sulfate, with coke. Firstly, barium sulfate will reduce by carbon in the coke, and it will form barium sulfide and carbon dioxide gas. Okay. For magnesium sulfide, we can form it by reaction of hydrogen sulfide with magnesium ether under temperature of 500 degrees Celsius. and it will produce magnesium sulfide and hydrogen gas. For the physical and chemical properties of sulfides, beryllium sulfide possess zinc blende structure. So first, what is the meaning of zinc blende structure? Zinc blende structure is a cubic closed packed array of sulfur atom and zinc 2 sit in tetrahedral sites in this lattice. Okay. For the heavier element of group 2, it will crystallize with a rock salt structure. What is the meaning of rock salt structure? The rock salt structure, or we can call as sodium chloride structure, form when each of the atom types form a separate face-centered cubic lattice, with the two lattices will interpenetrating each other and form. Okay, next is generally all of the sulfides in group 2 will display a strong phosphorescence. Okay, what is the meaning of phosphorescence? Phosphorescence is the ability to emit light or visible light without needing any combustion or heating process. Okay, so we move to the uses of the sulfide. For barium sulfide, it considered the first synthetic phosphor, while the calcium or strontium that doped with bismuth, it will produce a long life phosphor that we use in glow in the dark pigment. Okay, I think that's all from our group. Thank you. Do you have any question?